Alright, so question 14 is areas and volumes questions. Okay, so for this question, it involves two types of 3D figures. First, circular cone, um, here, and also one cylinder. Okay, so here we know that the height of x and y, alright, that means the cylinder and smaller circular cone is, this is 20, this is 24, okay, and then we know that the base radius, alright, of x and y, they are equal. Okay, so here we know that the volume of y is 800 pi. Okay, so for part A, we need to find the radius of y. So we know that the height of the cone y is 24. All right, so based on the volume of the circular cone, that means 1/3 pi r square h, okay, equals to 800 pi. And then for h, we know that it's 24 this time. Okay, so when we solve the equation, so r is equal to 10. All right, so the radius of y is 10. Okay, this is the answer of part A. Okay, for part B, in order to judge whether y and z are similar, we need to look at their height, the ratio of their height, whether it's the same as the ratio of their radius. Alright, so first of all, we know that the radius of the smaller cone y is 10, and from the question, we know that the radius of z is equal to the base diameter of x. Since the radius of x and y are the same, diameter means that it's a double of the radius. So we can conclude that the radius of z is 20. Okay, it's 20. That means the ratio of the radius should be 1 to 2. 1 to 2. Okay, so if we can find the height of the cone z, if the ratio of the height of z and y is still 1 to 2, then they are similar. Otherwise, they are not similar. Okay, so the way that we can judge whether they are similar, we need to find the height of the cone of z. Okay, so how do we find this? First of all, we need to know about the volume of z first, because we know that the volume of the z is equal to the sum of the volume of these two x and y 3D figures. Okay, so that means the volume of z is equals to the volume of x, that means pi r is 10 square h, plus the volume of y, that means 800 pi. Okay, so it should be 2800 pi here. Okay, so if this is like this, okay, using the formula of circular cone again, so 1/3 pi times 20 square h is equal to 2800 pi. Alright, so finally we got h is equals to 21. Alright, so if you compare the ratio, that means the ratio of the radius z, radial y to radius z is 1/2, but the height 24/21. Okay, so they are not equal. Of course, it's not equal to 1, 2. Okay, so we can conclude that they are not similar. Alright, so our conclusion is y and z are not similar. Alright, finally in part C, we are going to judge whether the sum of curved surface area of X, we just call this CSA, and the curved surface area of Y is greater than that of Z. Alright, so the most simple way is to calculate the CSA of X, Y, and Z all together. Alright, so first of all, for the CSA of X, okay, because it's a cylinder, hope you guys can remember that the formula is 2 pi RH. If you forgot, then nothing we can say. Alright, so for the curved surface area of X, that means CSA X is 400 pi. Okay, so and then next, CSA of Y. Hope that you guys remember the formula is pi RL. L means the slant height of the cone. Slant height means this one. This is L. Okay, so if we know that this is the slant height, then the way to find is to using the Pythagoras theorem to do so. Alright, so finally here will become 260 pi. And then for CSA of Z, okay, pi RL again, and of course this time the base radius is 20, and then the height is 21. Alright, so it becomes 580 pi. Alright, so after we can find all the CSA, so consider for the CSA of X plus CSA of Y, it should be 400 pi plus 260 pi, so it becomes 660 pi. Of course, this is greater than 580. Okay, so finally we agree the claim.